Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 11, Section 1, and today we're going to be talking about mass-to-mass calculations. So what we're doing, and please write this down, is you start with your mass of your known, convert it to moles of your known, to moles of your unknown, to your mass of your unknown. So this is the most practical type of problem because we need to know the mass of products, and we need to mass our reactants in grams. So this is really what you'll be doing in the lab. So please write that down. And then how to solve it. First thing, always write a balanced chemical equation. Then we're going to find the molar mass of our known, which is actually 1 over the molar mass. Then you're going to figure out your mole ratio, which is your unknown over your known. Then you're going to find the molar mass of your unknown. And then you're going to set up the problem and calculate. Mass of your known over 1 times 1 over your molar mass of your known times your mole ratio, again unknown over known, times your molar mass of your unknown. So you're going to have to find the molar mass of both things. And that's going to give you your answer. Alright, let's do it. In the decomposition reaction, how many grams of ammonium nitrate are needed to produce 33 grams of dinitrogen oxide? And water is the other product. Okay, so let's write down what we know. We know, let's do blue again, that we have 33 grams of dinitrogen oxide. 33 grams dinitrogen. Okay, that's going to be N2 oxide, N2O. And we want to know how many grams of ammonium nitrate. Ooh, we're practicing our formulas. So we're looking for grams of ammonium. Well, that's NH4 nitrate. Well, that's going to be NO3. Ammonium is +1, nitrate is -1. So they are a 1-to-1 ratio. Okay. Then we're going to have to figure out our balanced chemical equation. Oof. We're getting lots of good practice in. So if the decomposition reaction, how many grams of ammonium nitrate are needed to produce dinitrogen oxide? Okay, so we know we're going to be producing dinitrogen oxide and water, and we're going to be decomposing ammonium nitrate. So let's start with ammonium nitrate. Well, decomposition, so that's going to be solid. And then we talked about making nitrogen oxide, and you know that a non-metal oxide is going to be gas, and it said that water is the other product. Okay, so let's balance that. We have nitrogens, 2 there, 2 there. Let's go with hydrogens next. 4 there, only 2 there, so let's make 2 waters. Now let's look at our oxygens. I have 3 there, and 1, 2, 3. Well, that was pretty easy to balance. Okay, the next thing we're going to do is to find the molar mass of your known. So our known is dinitrogen oxide. So 1 mole nitrogen dioxide over how many grams? Well, you're going to need your periodic table and your calculator. So nitrogen is 14.01, and we have 2 of them. 14.01 times 2 plus oxygen, which is 16, 44.02 grams. 44.02 grams N2O. My 2 got a little crazy there. It almost looks like a subscript, but it's not. Then we're going to figure out the mole ratio. Our unknown, well, the one we're going for is ammonium nitrate. And in our balanced chemical equation, remember, we have 1 mole ammonium nitrate over how many grams dinitrogen oxide? 1 mole nitrogen dioxide. Okay, so then our molar mass of our unknown, which is our ammonium nitrate. Ooh, this one's a little bit trickier. So we have, again, 2 nitrogen, so 14.01 times 2, plus we have 3 oxygens, plus 16 times 3, plus we have 4 hydrogens, 1.01 times 4, for a grand total of 80.06 grams of ammonium nitrate over 1 mole ammonium nitrate. Okay, our next step is to set up the problem and calculate. We're going to start with our mass of our known, which we started with 33 grams of nitrogen, dinitrogen oxide. 33.0 grams N2O over 1 times our molar mass of nitrogen dioxide, which was 44.02 grams. So 1 mole N2O over 44.02 grams N2O times my mole ratio, which was 1:1. 1 mole ammonium nitrate over 1 mole nitrogen dioxide times my molar mass of ammonium nitrate times 80.06, that's a 0, grams nitrogen ammonium nitrate over 1 mole ammonium nitrate. Whew. All right, let's cancel out grams nitrogen, grams dinitrogen oxide, moles dinitrogen oxide, moles dinitrogen oxide, moles ammonium nitrate, and we're left with grams ammonium nitrate. All right, so 33 times 80.06 divided by 44.02. You want to grab out your calculator to do that. 33 times 80.06 quantity divided by 44.02, and I get 60.02 grams ammonium, that's an H, nitrate. All right, so let's see. We have 3 sig figs, so it's going to have to be 60.0. 60.0 grams ammonium nitrate. All right, and of course, the next thing we need to do is check, did we answer the question? How many grams of ammonium nitrate? We did. All right, now, is it a reasonable answer? So let's see. 33 grams of dinitrogen oxide, and 1 mole is 44, so let's say about 3/4 of a mole, and it is a 1:1 ratio. So we have about 3/4 of a mole of ammonium nitrate, and we have in 1 mole 80 grams of ammonium nitrate, so 3/4 of 80 is about 60. Did we get about 60? We did. We got a reasonable answer. Good job. All right, I'm going to have you write this down and then tackle it. So, tin 2 fluoride is made by the reaction of tin with hydrogen fluoride gas. Hint, the other product is hydrogen gas. If 30 grams of hydrogen fluoride are reacted, how many grams of tin 2 fluoride are made? So again, we're producing tin 2 fluoride, and you're also getting hydrogen gas, and you're making it by reacting tin with hydrogen fluoride. So tin and hydrogen fluoride are your reactants. So set up a balanced chemical equation, write out your steps, and get an answer. All right, good luck. See you later. Bye.